In this video, I am going to solve the problem 33rd from chapter 19. Oxygen gas having a volume of 1200 centimeter cube at 40 degrees Celsius and 1.01 10 power 5 Pascal expands until its temperature is 493 Kelvin and its pressure is 1.06 10 power 5 Pascal. First question, we are going to find the number of moles of oxygen present. In the second question, we are going to find what is the final volume of the sample. So here there are two information because the two pressure informations are given. Initially, the pressure is 1.01 10 power 5 Pascal, but after that, when it expands, its pressure change. So we have to work out very carefully. Clear? Okay. First of all, I'm going to write what is given in the question. So it's the oxygen gas and its volume is given. What is the volume? The initial volume of the oxygen gas is VI, which takes the value of 1200 centimeter cube. If you convert it in terms of meter cube, which is 1200 10 power minus 6 meter cube. And its initial temperature is mentioned here, which is Ti, takes the value of 40 degrees Celsius, and but I have to convert in terms of Kelvin, so I have to add 273.15, and when you add 273.15, we will get the answer in terms of Kelvin. So by that, the answer here is 313.15 Kelvin. And the final temperature also mentioned here after the expansion. And the final temperature is given here after the expansion. So what's the value? Tf is equal to 493 Kelvin. And also the final pressure. What's the final pressure here? So the final pressure here they mention 1.06 multiply 10 power 5 Pascal. I forgot to write the initial pressure here. What is the initial pressure here? 1.01 multiply 10 power 5 Pascal. So these are all the values which is given in the question. By using this, first of all, we are going to find how many number of moles of oxygen present here. So for that, I have to use the ideal gas equation. So what is the ideal gas equation? As we know, the ideal gas equation is PV, which is equal to nRT. So I'm going to use this equation for the initial case. So what is the initial case? PI VI, which is equal to nRTI. And I'm going to rearrange this equation in terms of N. So if you rearrange, what you'll get? N, which is equal to Pi Vi over R multiplied by Ti. Now I am going to substitute the value, and here the Pi takes the value of 1.01 multiply 10 power 5 Pascal multiply with Vi, which is 1200 multiply 10 power minus 6 over the gas constant value. What is the gas constant value? Which is 8.314 multiply with the initial temperature is 313.15. Now I am going to calculate the number of moles. I got the answer here as 4.65 multiply 10 power minus 2 moles. So this is the answer for the first question. Now we are going to find what is its final volume, right? So by using all this, we are going to find what is the final volume of the sample. So for that, again, I am going to use the same equation, but for the final condition, B part, P, which is equal to nRT. So this time I'm going to write everything for final condition. So now we are going to find the value of V final. So therefore, V final, which is equal to nRT final over V final. Now I am going to substitute the value. So what we'll get? The number of moles in the first part we got as 4.65 10 power minus 2, 4.65 multiply 10 power minus 2, and the gas constant here is 8.314 multiply with the final temperature here they mention as 493 Kelvin, right? 493 Kelvin over the final pressure is 1.06 multiply 10 power 5. So I got the answer here as the V final takes the value of 1.798 multiply 10 power minus 3 meter cube. So this is the answer for the second question. That's it. Thank you.